Hi everyone, this is the video lesson for 5.4, the derivatives of y equal to sin x and y equal to cosine x, part 1. Let's take a look at the warm-up. Number 1, what is the derivative of y equal to sin x? So again, if I just give you the final answer, if y equals to sin x, y prime equals to cosine x. And of course, the longer answer is by going back and using the first principle to show this. So again, if you go back to the beginning of this course, the first principle is given by the formula f prime, which equals to limit as h is approaching to 0 of f of x plus h minus f of x divided by h. And by applying the first principle, you will get to the same final answer. Number 2, what is the derivative of y equal to sine of f of x? So again, this is something that we've talked about in the past, also known as the chain rule, which we can apply for number 2. So if y equals to sine of a function, let's call that f of x, the derivative y prime equals to cosine f of x, and you multiply this by the derivative, which is f prime of x. And of course, I can put some brackets just to separate these two ideas. Number 3, what is the derivative of y equal to cosine x? Again, if all I'm showing you is the final product, the final answer, y equals to cosine x, y prime equals to negative sine x. And for the same reasoning, you can still go back to the first principle, which I wrote from above, and you can show that the derivative is negative sine x. Number 4, what is the derivative of y equal to cosine f of x? Again, just like number 2, you can apply the chain rule, and in this case, if y equals to cosine of a function, let's call this f of x, the derivative is going to be y prime, which equals to negative sine of f of x times f prime of x. And again, you can put some square brackets to separate those two ideas, just like that. Now, just to give you a preview, and I'm not doing this today in detail, but once you know how to do sine and cosine, of course, this is the preview for 5.5. You can now use these concepts to find the derivative of tan x, right? You can find the derivative. And again, I'm not going to show you what the answer is yet. You can try this. And of course, when you watch 5.5, part 1, you will see the derivation. But the hint I'm going to give you is this. If y equals to tan x, from grade 10 math, you've learned that tan x is sine x over cosine x. And by applying the quotient rule, and again, I'm giving you these hints here, and in combination with the two new ideas today, you can find y prime. And again, we'll come back to this once you watch 5.5. Now, let's continue with example number 1. It's not enough to understand the rules. Ultimately, you need to know how to apply them. So for number 1, it says y equal to sine of 3x, and they're asking you to find the derivative. So again, y prime equals to cosine 3x times the derivative of 3x, which is 3. And again, I'll put brackets around there. Now, I'm going to make a mistake because this is the mistake I've seen very, very, very often, and I want to make sure you don't make this. So again, it's not enough to know what to do. You also want to make sure you know what not to do in order to become even more confident. So the mistake I see is this. One student will write down cosine of 9x. They get their quiz back, their test back, and they are unhappy. And of course, the reason is you have to follow BEDMAS, right? You cannot just start randomly multiplying in any sequence that you like. So really, again, those square brackets I've mentioned in the warm-up, I'm going to put them back. So the correct answer is y prime equals to 3 times cosine of 3x. And again, if you like, you can put a box around it, just like that. Part B, cosine of 5x. Again, y prime equals to negative sine of 5x, and you multiply this by the derivative of 5x, which is 5. Again, you can put the brackets around them, even around 5x. The final answer, y prime, is going to be negative 5 times sine of 5x. And if you want to put brackets, that's fine. And I'll even put a box around the final answer. Let's keep going. Part C, y equals to sine x to the power of 2, or sine x squared. And again, form the habit of writing everything in terms of exponent form, just to see it a little bit better. This ideally would help you to think about the chain rule as well. So again, you bring the 2 to the front. You copy sine x to the power of 2 minus 1, which is 1. Don't forget to multiply by the internal derivative. And when you differentiate sine x, it's going to be cosine x. Now, if you just copy this, y prime is going to be 2 sine x, cosine x. And I do want to say this is fine. This is more than enough in terms of what we're looking for. However, I am going to give you a bonus line, which I'm not expecting you to write every single time, but it's definitely something that you can relate to with double angle formulas. So 2 sine x cosine x is really sine of 2x. So that's another answer that you can think about when you see 2 sine x cosine x. Okay. Part D. I want to make sure you try some of these, and of course I'll take it up in a moment. So y equals to x squared minus cosine x in brackets quantity cube. So take a moment, press pause, just try this. When you press play again, I'll be right here. Okay, let's take a look. Y prime equals to, again, I'm applying the chain rule. I bring the 3 to the front. I copy x squared minus cosine x to the power of 3 minus 1, which is 2. And I multiply by the internal derivative. So when you differentiate x squared, that's going to be 2x. When I differentiate cosine x, that's negative sine x. But since I'm subtracting, right, it's minus and then negative sine x, just like that. Now here comes the final answer. And again, you can bring the 3 to the front or just leave it as is. You can bring 2x plus sine x as the second part. And then the last part is going to be x squared minus cosine x quantity squared. So I hope this is in agreement with the answer you have on your paper. That's how I know for sure you're in phase and you're synchronized. Let's keep going. Example number 2. Determine the equation of the line tangent to y equal to sine 2x, where x equals to pi. So when you finish this, make sure you express your final answer in standard form. Express your final answer in standard form. So instead of pressing pause and trying this and pressing play again, just try this. And when we reconnect in part 2 of this video, I will take it up accordingly. I hope this makes sense.